morning, everyone. How's NDC Oslo so far? So today's talk is about scaling large Angular apps. My name is Jad Joubran, and I founded a startup called ETOB in the MENA region, which connects patients and doctors online. And right now, I'm teaching with Go in Brussels, Amsterdam, and Lisbon. And I love open source. So I want to start by telling you exactly what I mean by scalings, because it can mean literally anything. And what we're going to cover today is how we can scale on an Angular project the number of developers, and how we can scale the performance and the functionality. And by functionality, I mean how can we keep on adding functionality to our project, because with time, sometimes it can get very hard. And I will start with the takeaway of the talk, which is scaling requires a solid code base. So this is why we will be exploring, we will be talking about JavaScript. I'll be talking about component-based architecture, even API calls, and then performance, and at the end, I'm gonna show you how Angular 2 is fixing all of the problems, because mainly today I'm focusing about Angular 1. So let's talk about JavaScript. And technically, this is how it all started. In 1997, we had ES1, which is ECMAScript 1. And then a year later, we had ES2. And then 1999, ES3. And then for 9 years, almost nothing. They were working on ES4, which wasn't released. But then we had ES5, which is what you know today, which is what you're using, ECMAScript 5. And then for 6 years, we've been using ES5. No new additions to the language, no new features, just like it was. So as I told you, we've all been using ECMAScript 5 because we know it's supported on all browsers. But the nice thing is that we will be having new releases every year. This is why we have ES 2015, 2016, 2017, and so on and so forth. So I'm going to talk a bit about ES 2015. And technically, you already know ES 2015. That's because your ES5 code already runs inside ES 2015. So if I want to put this into a Venn diagram, you have, this is your ES5 code. And then you have this superset, which is ES 2015. And then you have another superset, which is ES 2016. And now the reason why they created ES 2015 was to fix some of the ES5 problems. And there are a lot, honestly. And they wanted to bring modern syntax and new features to the language. And if you're wondering how it works, like how can you write ES 2015 code if it doesn't run in the browser, because we don't have the perfect browser support yet in all of them, what we do is we write in ES 2015, the new language, and it gets transpiled into ES5. We call it ES5 compliant because all the browsers know how to run it. And you can use a tool such as Babel for this. So I'm going to show you a few ES 2015 features without taking a lot of time on this. So we've got template strings, classes, let and const, arrow functions, and a lot more. But these are the only things that I'm going to show you today. So if you were in the previous Angular talk, you've probably seen template strings. They're technically like regular strings, but with backtick. We call it the backtick operator. Sorry, the backtick character. And they allow you to do multi-line strings just easily without appending, without concatenating a string with \n to another string, etc. And you can finally do interpolation. So if you got a variable called name, you can do interpolation inside of it, and this by using this $, curly braces, and then the variable name. And then we've got classes. So in this example, I'm creating my own custom class, which I called person. And it has a constructor, like an initialize function, that has 2 arguments, first name and last name. Then I can say this.firstName equals first name, same thing for last name. So I'm setting the attributes. Then I can create my own custom function, for example, get full name. And I'm using here template strings, which returns first name, space, last name. And then if I want to call it in my code, I can say var John equals new person, and then John.getFullName. But I have to tell you that I'll keep it for a few seconds. OK. So that's the code behind the classes. It makes things more neat, but I have to tell you that this is only a syntactic sugar. So everything you know in the prototype object-oriented JavaScript is still the same. This is just a way to make them look nicer. And then we've got arrow functions. So this is an example of an arrow function. I can say var say hello equals, I start with the arguments and then do the arrow, and then curly braces and have my code inside. It might look a bit weird the first time you see it, but it solves the problems that I'm not going to talk about today, which we call the lexical dis. But it's very useful and it's short. Then we've got let. So for example, inside this for loop, we create let x equals 0, and we can do console.log x inside the for loop. But outside the loop, we do not have access to x. This is what we call x is block scoped. Not like the var, which is when you create it inside the for loop, you have access outside of it, which can lead to several issues later on. So, and then I'm going to talk a bit about TypeScript as well. So TypeScript compiles to regular JavaScript, just like we used to do with ES 2015 to ES 5. But if you look at this example, which adds two variables, x and y, you can actually tell TypeScript that I expect x and y to be of type number. But don't forget that when you compile this to, or transpile this into JavaScript, the types will be gone. And the easiest way to show you the benefit behind this is you cannot do add string to integer. I know this is a dull example, but this is the simplest thing I can show you. So it can warn you when you do things wrong. So some TypeScript benefits are static analysis, are actually all the benefits we get from static analysis, because we have, it is now typed. And we also get code completion, which is also awesome in the text editor. So when I press dot, I get exactly what I should see for this function or for this variable. And as John Papa said, if you screw up, it'll tell you. That's the main benefit of TypeScript. And then there are other TypeScript features. For example, I showed you a bit about types, and I'm really interested in interfaces. So I can create an interface, call it I-user, I for interface. It's just a naming convention. And I know for sure that this interface will have a first name of type string and a last name of type string, and can have optionally an age variable, an age property of type number. The optional is because of the queries, the question mark. So you can think of interfaces as a code contract. And you know this is very beneficial in teams if you have a code contract. So with the same interface, I hint the user variable to be of type IUser. Now I know that I can get the auto-completion of user.firstname, and I know for sure that it should exist. So these things are very beneficial when you're working in a team. So as a recap for all the JavaScript that we've been talking about, everything is transpiled into ES5 right now, but it can change in a year or two. So once we have ES 2015 support across all browsers, you do not change your code. You only change the config file, and instead of transpiling into ES5, we transpile into ES 2015. And so once again, the Venn diagram is we have ES5, then we've got a superset, which is ES 2015, and then another superset, ES 2016, and we have this huge superset, which is TypeScript. So TypeScript allows you to use the future today, allows you to use all the nice things, all the nice features just today. So that's it about JavaScript. And now when you're starting a new project in Angular, we often know that if you want to set up your project by yourself, it's going to take a lot of time. And it's almost impossible to get right, because there are so many things involved. And if you think you got it right, just wait a couple of weeks and you will start seeing that the folder structure is not working properly. So I would like to introduce you for an Angular 1 generator that can generate your app. So assuming you have Yo, which is Yeoman, a generator, and then Gulp and Bower installed, you can install this generator and then just run Yo gulp-angular. And what this thing is going to do is just ask you a couple of smart questions. I summarized some of them. So would you like to use a REST resource library? Which means it gives you options like, would you like to use $HTTP or maybe $resources or REST Angular? And you can choose whichever option you like. Then it asks about the UI framework. So would you like to use Material Design Lite, Angular Material, Bootstrap, or even no UI framework? You can choose between less, SAS, or stylus, etc. So you can really customize it to fit what you're looking at, what you want. And then mainly for JavaScript pre-processing, you can choose between ES 2015 by transpiling using Babel, or you can even choose TypeScript, or you can just choose plain JavaScript. And then basically that's it. At the end, it will run npm install. So it'll probably take forever, but that's a really nice starting point. And now I need to introduce you to component-based architecture. So you're probably seeing that it's really all about some kind of having a solid code base. It's not about doing one particular thing. And component-based architecture is now possible because of Angular 1.5. And it kind of mimics what's going to happen in Angular 2. So you're not learning something that you will need to throw out in the garbage very soon. And the benefits of component-based architecture is that the components you build are testable, reusable, and isolated. Isolation is very important in teams. So I will talk about this later on. Now, how many of you are still using ng controller? Raise hands up. OK, so I will start with some of the best practices that there have been circulating in the community that we need to get rid of plain controllers. And the simplest reason is because plain controllers like ng controller has been removed in Angular 2. So what we do instead, we stick to components. Now, of course, inside the component, there will be a controller, but this controller is strictly to be used by this component. It's not a global controller available everywhere in your code. So we only stick to components. And I can show you a quick, like from controllers to components code. So instead of having div ng controller and then side menu controller, you can actually have a much more expressive syntax, which is a component. I called it side menu, and I can even pass in custom attributes like theme equals dark. And if you're wondering how would the code behind this look in ES 2015, it would look something like a class, side menu controller, which has a constructor that does nothing for now. And then we can register the component by saying angular.module app and then .component. I'm going to register it as side menu with the lowercase s and capital M. And then I need to point it to the correct template URL. So I say template URL side menu.component.html. This is where my view is going to be. And I reference the controller by saying side menu controller. So that's a really nice way to start writing components in Angular 1.5. Hands up for $scope. Come on, don't be afraid. OK, so you're taking a picture. OK. So we need to get rid of $scope. The reason why, once again, is because it doesn't exist in Angular 2 anymore, and it just clutters our code without any beneficial reason. So what we're going to do instead is we will bind to this, keyword this, by using the controller as syntax. How many of you have been using the controller as syntax? Great. So instead of having this terrible thing, we're registering a controller and then injecting $scope, etc. We will be fixing it into, and in the view you would have a name variable. We would be fixing it to use the ES 2015 syntax and the controller as. So we would have a class, and then in the constructor I do this.name equals Igor, and then when I register the component, the only thing I need to change is add controller as $CTRL. Has anyone been using VM instead of $CTRL? Yeah, it's basically the same. They just changed the documentation, the best practice for it a few weeks ago or a few months ago. And by the way, if I omit controller as, it would still work because this is a default here, but I needed to add it so I can tell you about it. But then the only thing that changes in the view is that you need to prefix name with $CTRL. So this is where you've probably seen vm.name. And again, that's how you can benefit from this new syntax and make your code look much cleaner. So then I'm going to talk about components and directives. So there has been a bit of confusion between components and directives. Should I use a component? Should I use a directive? Or is there even a difference? I'm just going to briefly summarize it that components are meant for UI components. I know I used the word component again, but so when you're building your application, you can think of UI components as Lego blocks. So I have this user detail here. I have this to-do entry, user info, user profile, those components, and when I add them together, I will have a page or a website. And components promote best practices by default, like the controller as syntax, like the bind to controller, which we'll not see, but it has the best practices built in. And then for directives, so they're mainly meant for DOM manipulations. If you're doing DOM manipulations, think of it as if you were doing your own ngIf, you would use a directive. So they're not mainly for doing UI components that you will use for your UI. And then for component isolation, which I mentioned is very important in Teams, I will start with the folder structure, which is something you will get by default if you use the generator that I showed you. So the folder by feature architecture allows us to group related features into feature files into one folder. So everything that relates to one feature will be in the same folder. And this is easier to maintain, especially on the long run. If you go back in 6 months and you look at the side menu folder, you know that you will find everything inside, like the side menu.component.html, this is the view. Side menu.component.js, this is the component JavaScript file. And I also have .spec.js for the tests. And for example, all the SAS or less files in the same folder. And then the funniest issue is scoping CSS. Like, we want to avoid class collision. In Teams, you end up having the same classes being used maybe on different components, and changing one property here would conflict another property. So you end up doing a meeting, and after the meeting, we agree that we will have unnecessary long names to avoid this class confusion. And it's not really a nice way to deal with it. And also, we want to scope CSS because we want to keep our files short. So I would suggest using naming conventions like BAM or suit CSS. Has anyone been using BAM or suit CSS? None. OK, so I will introduce suit CSS, but you can use BAM or any other naming convention that really thinks at the component level. So on the top, I will show you the general rule, and below, I will show you an example. So .component name, in our example, it's going to be a button. So if you're building a component for a button, we would start by saying .button with a capital B. And then we can have a modifier. And the syntax for the modifier is by having the dash dash. So .component name dash dash modifier name. In our example, it could be something like button large or button dark. So immediately when I see this dash dash syntax, I know that this is a modifier. So this is something I can add maybe next to the button to change the way it looks like. And then we've got descendant. So component name dash, only one dash, descendant name. In our example, it could be button dash icon. So now, again, I immediately know that this is a descendant of button. And finally, we have the is state of component, for example, like button is active. So I will show you an HTML example of this. We can have something like this, div in the class button. Then inside of it, we told you about the descendant. We can have a button icon. And then you can have the modifier. So you can have button dash dash large, or you can remove it. But that's how the modifier is meant to be used. And finally, you can also use the is active. So once again, the purpose behind this is to scope CSS, because up until now, this is the best thing we had. I will mention how Angular 2 is changing this at the end of the talk. And what I really like about Suit CSS is that we don't have those dangling classes anymore. Just like Twitter Bootstrap, you've got .navbar, .btn everywhere, and if you've got some junior developers on your team, they'll probably end up using .navbar, add display flex, and then the whole website doesn't work. So what Suit CSS tells us is it's better to prefix our helpers with U for utility. So all the utilities will be prefixed with u-something. That way, you know that this class is being used everywhere, and you should probably not have a lot of them. And now for API calls. This is my favorite part of this talk. Although people will be wondering, you might be wondering, what does API calls have to do with scaling large Angular apps? So I'm going to ask you, how many times do you call your API? And what I mean by this, if you look for example, $http.get and .post in your code, how many times do you think you will, how many results do you think you'll get? Raise your hands for 30 plus. You can raise your hand again, because how many of you think it's 50 plus? And sometimes it's also 100 plus. So if you're doing something that frequent to your code, why not take a step back and think how we can make it more fluent, how we can avoid boilerplate code. So in this example, I'll be using Restangular, which is an API library. And I will use Restangular to remove all the boilerplate code so we can keep our code dry, and dry as in don't repeat yourself. And at the end, we will notice that we will have a fluent syntax. So you don't have to use Restangular. You can use $HTTP and build your own functions on top of it. Or you can use another library, but just for the sake of this example. So, and the first thing I'm going to do is I'm going to create my own API service. So this is a regular Angular service. I called it API. And I just return Restangular with a custom configuration. And we will be configuring Restangular step by step. What this means is from now on, you will see the word API. You can think of it as $HTTP. But it's my own version on top of Restangular. So I'll start with the basics. And it's really good to, with the base configuration is very important, because imagine if you were doing something like api.get, and then you have this whole base URL, and then /users. Once again, api.post, all of the URL. It doesn't really make sense. If you want to change this base URL, it's going to take a lot of time, and it's not best practice. So what we can do instead is we can just configure, in the configuration part that I showed you, you can just configure and set the base URL to something like example.com/API/v1. I know this is simple, but it will save a lot of time later on. And then in your code, you would just use it as api.get, users, api.post, articles. Has anyone been doing something similar with $HTTP? OK, we're on the right track. And this allows for environment-based base URL, which is also simple, but you can easily flip the environment variable and then change the base URL without adding some tooling. So if you're on staging, you can flip it. If you're on testing, you can flip it. And then for all remaining cases, you're on production, so we need to use the production endpoint. And then same for default headers. If you're sending a particular header on every request, or maybe every subset of requests, you can just set it from the configuration. In this example, I'm doing content negotiation with the server. I'm particularly asking for v1, and I'm asking for a return type of JSON. But it could be any header that you send. You can just set it from the configuration, and then you forget about it. Now for the even more interesting part, our request interceptors. How many of you have been using them? This is great. So a request interceptor is basically a method that gets called before every API call. So for example, this function, which uses the arrow syntax with add request interceptor, this function inside the block will be called every time before sending the request. So what this allows, I'm going to show a few examples. You can do everything related to HTTP authentication. So whether you're doing basic HTTP authentication, JWT, JSON Web Token authentication, or even token authentication. For example, you can read a token from the local storage if it exists, and then, again, check if it exists and add a custom header instead of doing it in a weird or bizarre way. So you can manage all your authentication from inside the request interceptor. And then we will see the same, but for response interceptors. So a response interceptor is technically a method that gets called after receiving data from the server, every time after receiving data. And the syntax looks almost exactly the same. But this allows us to do much more powerful things. So if I use both the request interceptor and the response interceptor, we can manage the loading state from one place of the app. So I can set a request interceptor to start a loader. This is what loader service.start does. So when we send a request, we start a loader, and then when we get the response back, we stop it. So I find this really elegant solution, especially in teams where you have sometimes developers forgetting to start the loader or forgetting to stop the loader. So you can manage all of this once and then never worry about it. And one more thing with interceptors, which is for errors. And once again, error interceptors allow you to set a function that gets called after there is an error with the server. So this allows us to do even more things. So also same syntax. And the first example is handling unauthorized requests. So if your server sends back 401, you want to redirect the user to the login page. You can do this by checking the response to status for 401 as in unauthorized. And then you can redirect the user to the login page, for example. So you do this once, and then later on, when you're using your API service, you don't worry about it anymore. And another thing I like to do is to manage validation errors, because validation errors occur on almost every single API call. So this is what we used to do before. So you would say API.get users, and then you resolve the promise with .then, and then you have to pass in two functions. The first function is the success callback. OK, what should I do if everything was successful? Then the next argument would be, what should I do if there was an error? So I would go and inject the toast service, and then I would show error.data, error message. And you have to do this every single time. By the way, this is how a toast would look like, for example. So instead of doing this tedious process on every single API call, what you would do is start by configuring it. So 422 in some of the frameworks, 422 means unprocessable entity. So in most frameworks, it's used for validation errors. So if there is a 422 error, I will take the error message from it and then open a toast. So with that piece of code, you would have solved the validation for most of your application. And then you can just simply worry about the success callback. So you do API.get users, then resolve the promise, and then only worry about the success callback. And if you're wondering that this is making me lose my flexibility with the code, that is not true. Because you can still pass in a custom error handler, and it will be executed. So you're not losing the flexibility of having an error function, but you're just setting a generic way to handle all the validation errors. So you can do things for other responses. I just showed you for 401 and 422. And one last thing with dealing with APIs. Sometimes in some projects, you're dealing with multiple APIs, and we already saw how we can do it. Because remember, I created a class API that extends REST Angular. So you can create another API, for example, API 2, that extends REST Angular and has completely different configuration. So this is highly customizable and will save you a lot of time. And as a summary for the APIs, look at instead of doing this, actually, instead of worrying about the headers, the base URL, success, and callback functions, you can now do all of this with just this. And now onto performance. So I'll define my strategy first. The strategy for performance is not going to be about micro benchmarks. I'm not going to tell you to use a particular thing instead of another thing, because that's not really the best way to approach performance. Because in most scenarios, you have to rely on profiling and see why this particular issue is slow. However, I'll try to give you as much as possible of generic rules that you can apply. And don't forget that the right optimization technique will outweigh thousands of micro benchmarks. So this is why we tell you not to waste your time on micro benchmarks. So Angular has something called watchers. But before talking about watchers, I'm going to quickly mention the digest cycle. I'm sure you've heard about it. It's basically Angular's way of checking what has changed. So Angular does some checks, okay, what has changed. And then if it picks up some changes, it needs to update the UI. That's basically how it works. And how does it check for changes? It goes through a list of watchers. So things that Angular kind of watches. And it sees if they change. Now, what are watchers? So watchers are created when you have an expression or one-way data binding if you're using directives like ngIf. So basically, every time you're using the framework, you are setting watchers without knowing it. And normally there is no problem with this, but when you set too many watchers, the app becomes to feel a bit more responsive. That's because the digest cycle is taking up more time than it should. And this is a problem that you should solve if you have too many watchers. And I'm going to have to talk before about two-way data binding. So if you're using the new component, this would be the syntax for it. Before, we used to use the scope 2 points. But in the new syntax, it would be bindings, and then I would say theme, and then equal sign for two-way data binding. And the view would look something like this. So side menu theme, then I'm binding to another variable, another component, $ctrl.theme. And this is two-way data binding because we're using the equal sign. So if we want to know exactly how two-way data binding, we need to explore the two factors of two-way data binding. And the first one is parent to child, which means when the theme changes in parent, go ahead and update it in the child, which is the theme, which is the side menu. And then for the other aspect, it would be child to parent. And then it means when the theme changes in the child, update, wait, could you do that in Angular? So a lot of people had no idea that you can do that in Angular. So, or if you know about it, you probably don't use it. What I mean by this is, in most scenarios, we don't really need two-way data binding. This is why in Angular 2, it has been renamed to input, and everything is one-way data binding by default. So we don't have to pay for something that we don't need. This is why we can start using the one-way data binding syntax in Angular 1.5, which is this less than sign. And instead of the equal sign for the theme, I would say less than, and now we have only one-way data binding. Then we've got lazy loading. So lazy loading means we should only load what we need. Without loading, instead of loading the entire application, we just load exactly what we need. Because the benefits of this is that it reduces the footprint, the JavaScript footprint. So we have the footprint for download and footprint for execution. But unfortunately, in Angular 1, lazy loading is not supported by default. You can do some workarounds for it, but it's not going to be very easy. However, I can give you an advice, which is you can create separate modules and then bootstrap different applications. So if you're building a web application that has a client-facing app and an admin interface, then it doesn't really make sense to have only one application. Instead, we will have the app, which is for the client, and then we have another completely different app, which is the admin. So now, as if you have two independent Angular applications, and you're not loading something that you don't need for the client and vice versa. then for caching, how many of you are doing caching in Angular? Just 4. So caching doesn't have to do anything with Angular. It's not really, what I'm going to say is not really Angular specific. I'm just reminding you that if something takes a bit of time to get from the server, then, and it doesn't change frequently, then it makes sense to just cache it. So it's just a reminder that sometimes the optimizations need to be done are not really relevant to Angular. They are the optimization techniques that you already know. So you can cache in memory, in local storage, depending on your purpose. If something changes every week, you can also set an expiration for it, so it can expire after a week. And so basically, that's it for caching. Then I'm really interested to know how many of you have heard about the Angular production mode? Okay, 3. Even the Angular docs haven't heard about the Angular production mode, or they forgot it. So first, development mode. So by default, Angular runs in development mode. And the development mode is basically Angular goes and attaches debug information to all your elements. Have you seen this ng-scope before while inspecting? Yeah, so this is all Angular running in development mode. Now you're probably wondering, why do they do it? So they do that because they need to make tools such as Batarang. They need to make it possible to work. So this is only for debugging purposes. So they go and update every element with some data that is relevant for debugging. So are you thinking what I'm thinking? Do you need this in production? Of course not. So, and yes, you can disable this. You can disable development mode, which technically brings you into production mode. And Angular will run perfectly fine without this debug information. So it's only for debugging. It doesn't matter. Angular can still work without it. It will be actually more optimized without it because Angular doesn't have to touch the DOM and update some classes if it doesn't need it. So basically, this is performance improvement for free. So don't forget to switch to enable production mode before deploying on production. And the code behind it is very simple. You just inject $compile provider in the config and disable. You say debug info disabled and then false. Enabled false. But now, what if we have something wrong on production and you need to debug? It's still possible. You can just open your console and run angular.reload with debug information. It's going to reload the page and only set debug mode for you. I think they do it using a cookie. So you don't lose the debugging flexibility you had on production. Service workers. Hands up for service workers. Nothing to do with Angular. I will be completely honest with you. So this is not Angular specific at all, but I will show you what I mean by this. So first of all, a service worker is a script that is run by your browser in the background and separate from the web page. So even if the web page is not running, you can have a service worker running. And the service worker allows us to do features. I think you've been hearing about them, such as push notifications on the web, even offline support, or even intercepting requests. So all of these new stuff, you can do them using service workers. And the best approach to use service worker is to build an app shell structure. The app shell structure means you have something that loads initially that will hold your application. It's like a placeholder for your application. And this is supposed to load as soon as possible, so as fast as it can. And every time you enter your website, this app shell will load super quickly, and then it will start requesting other resources. So this is going to give your app a native-like performance. So for the web, this is like the peak of optimization. I mean, how it looks for the user. In terms of user experience, you go into a website, and then under a split of a second, the app shell would start loading. And I will show you an example of this. So here's the app shell. Here's the application shell on the left. You can see we have the side menu, and we have this header, and then just a white placeholder for the content. So this is supposed to load as fast as possible, and then it will request the content on the right. If you think about it, that's how mobile apps work. When you click on an icon, you've got a splash screen, and then you've got a header and a sidebar maybe, and then placeholder for the content, and then you see a loader. So we are now able to do this on the web, and I'll show you an example of how we can use service workers to make this app shell load very quickly on repeat visits. So on the left, you've got first visit. It's going to take a bit of time. And on the right, it will load as quickly as if you were on a native mobile app. So that's it. In 0.8 seconds, you have the app shell structure loaded without having all the information that you need, but it will show the user that there's something happening. So this is great for user experience. One more time. Okay. So I can't really dive a lot into service workers. I just wanted to introduce you to service workers. And again, they're not really Angular specific, but if you're looking to do this kind of user experience, then you would have to use service workers. And you can use them with Angular. And now for testing. So testing is very important, although some people don't like to do it very correctly. I'm going to tackle a different perspective about testing today. So, but before, we know that writing tests is very important because it gives us the flexibility to optimize without breaking the previous functionality. So if you learn something new and you want to refactor this component, you can just make sure that it still works if you have a solid unit test case. And obviously, this is a requirement for maintaining large Angular apps or large apps, and which will allow us later on to scale our developer team. But what I'm going to talk about today is, I think it's rarely being talked about, which is the developer experience behind tests. Because I'll be honest with you, I don't like writing tests in Angular. The syntax is horrible, and you've got so many $ flying around. So I'm going to introduce ngmock. And ngmock allows you to write tests for Angular in a declarative way. So start by saying ng-describe, and then I name my test, and then set whatever module I need to inject. And then I can tell ngmock, I want to test the side menu element. So I pass an element and say side menu. And then I can write my test suite inside of it. So that's really a nice way to avoid all the boilerplate code that you need to write tests. Some teams create their own helpers, but you can also use something that's already out there and it works. And another huge benefit of ngmock is if you want to mock HTTP. Has anyone mocked HTTP before with $HTTP backend? Have you suffered? Yes. So look at the nice syntax. So once again, I'm injecting this element, and I'm selecting this element. I want to test this side menu element, and I can also easily inject $HTTP. And then you specify that for HTTP and for GET requests, if I get this URL, API/pages, it should return this. That's basically it. And now you can carry on and write your tests without worrying about all the messy stuff behind the scenes. So that's basically it for Angular 1. And now I'm really excited to tell you how Angular 2 has been already thinking about most of the problems and their new approach to solve all of these issues. So we will start with the same structure. You already know that Angular 2 comes with TypeScript. And the next step would be setting up the project. And to set up the project, you've got Angular CLI, which is the official tool to bootstrap Angular, to start Angular apps. So npm install ng-new, and then your app, and then basically you have all the development lifecycle that you would need. So if you want to create a component, like you've got some sub-generators to create a component. So it will generate the boilerplate code you need for components. If you want to run a test server, you've got that working. If you want to run an optimized version and deploy it, it's also built in. So we've got everything you need inside Angular CLI. And then for component-based architecture, as I told you, it didn't change a lot except for the syntax because we now have TypeScript. It's kind of still the same, but we get more formalized input properties and output events. And if I want to map this to Angular 1, the input properties would be we used to use the equal sign for two-way data binding, which is not correct, which is the same as the less than, one-way data binding. Then the output events would be similar to using the ampersand and then the function. And at input and at output are the decorators that you use to inform Angular that this is an input property and this is an output event. And then do you remember the mess for the styles using all of these naming conventions? So there's something called shadow DOM, which you can think of it as this section of the DOM will be kind of completely independent from the rest. So Angular 2 allows us to use this functionality as of today. So it means that every component in Angular will be isolated from the rest. So I can use a .active class and not worry about having a different component or a different developer using it somewhere else. And this is something that works natively in the browser and new browsers in Chrome. But because we need our app to work everywhere, what Angular does is they have an emulated mode. So emulated, it means they take this class and then they add some attributes to make it only match your component. So you can actually decide if you want to have the emulated mode or if you want to have the native mode, or you can even disable it. So this is a really nice feature. You can just go back to use those image selector, H2 selectors, if you're building small components without worrying about the cascading stuff of CSS. Then for lazy loading, it's a good thing that Angular 2 comes by default with lazy loading. As you already said, the router has been deprecated, but I think the new router also supports lazy loading. And so it means you can just load the components that you need. And because of the new way, the new dependency injection, how it works, it will resolve only the components that are required for this route, and they will be loaded. So this is less JavaScript footprint. You download less stuff and less execution for JavaScript. Less time waiting for JavaScript execution. Another feature of Angular 2 is web worker support. So all of these features are mainly targeting performance, at least the web worker. And the web worker is different from a service worker, but it allows you to run computations in the background of your page on a different thread, so without blocking the main thread, because all your JavaScript code is running on the main thread. And if you do something that takes a bit of time, your UI will start having degraded performance. So this has been in browsers for a few years, I think, but no one has been using it because it's a bit complicated. In order to implement thread safety, you don't have access to the DOM inside the web worker, so no one was really using it. But what Angular 2 gives us is they have optional support for web workers. And if you stay within the boundaries they define, you can make your code and Angular's code run in the web worker, which also means you get more performance benefits because you're running in a separate thread without blocking the UI. Then this is something really exciting, static template compilation. So everything that Angular needs to do to prepare your templates, instead of doing it in the browser, it can now be done on your machine. And then you deploy optimized code. So it means that Angular can compile all the templates at build time, which basically means Angular is removing all the overhead of the framework. And now you're delivering optimized templates to the view. So that's how they were able to make templates render 5 times faster than Angular 1, whether it was the first view or repeat view. So we now have much faster template rendering on the client. So you can think of it as, for example, when you write this curly braces, if they need to be transpiled into something else for Angular to understand, Angular will already do this in your build tools. So when you write your code, it will generate the optimized version, which will be then served to the browser. Then tree shaking. So the technique of tree shaking has been for a lot of time now, but I'm really excited to tell you that there is support for tree shaking in Angular 2. You can think of it as only pay for what you use. So if you're only using a couple of things in Angular 2, you have the possibility to generate a version of Angular 2 that only has the things that you need. So instead of serving the whole Angular framework, you only serve the parts of it that you need. And this is something that can be done automatically. And this is another benefit of TypeScript. Because of the TypeScript ecosystem and that Angular is written in TypeScript, they can know exactly what functions you require and what functions you don't require. Another interesting thing we have is server-side rendering. So by a project called Angular Universal, server-side rendering is when you render the component on your server, on the server side, and then return it to the front end. So this will give you a better perceived performance, because instead of waiting for the whole page to load and for Angular to bootstrap in order for it to render the component, you will serve a component that is already pre-rendered. And then later on, when Angular loads, you can do everything that you used to do. Now, this is the main benefit, but you can finally get SEO optimization. Now, we know that Google, as a search engine, can crawl Angular apps, but what about the other search engines? So now, because we're serving something that is already rendered, we don't have the SEO problem anymore. And same thing for the site previews. So remember when you used to share an Angular website on Facebook and you get those curly braces or ng cloak or whatever. So those are some of the Angular 2 features. There's also performance features. I mean, there's also one that's I didn't mention here. I can tell you about it, which is the change detector for Angular 2 always runs a VM-friendly, an optimized version of JavaScript. So the way they used to do it is they used to have one change detector for all your Angular app. And this is going to use polymorphism in JavaScript. And at the VM level for V8 and all of those softwares running JavaScript with a JIT controller, JIT, just-in-time compiler, it will be slow, because when a function gets repeated a lot, which is what we call when a function is hot, the just-in-time interpreter will not be able to optimize it, because every time you're giving it different inputs. But now what they're doing with Angular 2 is that they create a change detector for every component, which means when this change detector gets hot on every digest cycle, it will be already optimized by the virtual machine, which is another performance benefit. So once again, as a closing thought, it's the same thing. Scaling requires a solid code base. So it's about using all of these best practices, thinking ahead of time. And again, Angular 2 makes things a lot more easier. I hope you enjoyed this talk. You can find it online on this URL, and I'll be happy to answer your questions. Thanks for your time. Yes, guys, can you please go that way and vote? Because it's not working on that side. And if you've got any questions, we've got 5 more minutes, or you can catch me around today.